Delete in circular linked list. Deletion, it is the process of removing an existing node from a linked list. Here we are considering circular linked list, and let us see what are the sub cases of deletion in a circular linked list and how are we going to handle those. Mainly we'll be going through three sub cases. First case is deletion at the beginning of the list, that is deletion of the first node. Second is deletion at the end of the list, that is deletion of the last node. And third case is deletion at a specific position in the list. These are the three cases we'll handle. So coming to deletion, two things that you always have to keep in mind. First thing is to check if the list is empty. How do you check if the list is empty? If your head pointer is not pointing to anything, that means your list is empty. It does not have any elements. You cannot delete. So this is the first thing. Second thing that you have to check, if it is a list having only one node. Some lists may have only one node. So head will point to that node and it will have a pointer to itself because this is a circular linked list. So if there is only one node, you have to just delete this node off and make head empty. That is what you have to do. And remember, whenever you are deleting any node from a list, make sure that you free that memory. That is, after you delete it, remove it from the list. Let us say there is only one node. So you made head as null. That means this is no more a part of the list. But this node is still there in memory, which you have to free off by using free operation. So this is in case of a language that is not having automatic garbage collector. If it is having automatic garbage collector, then in that case you don't have to deal with it. It will automatically deal. Anyway, just keep in mind that memory should be freed by some means. Okay. So let us get into this. So two things to keep in mind. One is if it is empty. Second, if it is having only one node. These two cases you have to deal separately because there is no concept of beginning, end, or at a special position. So now we are going to the sub cases. Let us say this is your list. You are having three elements in the list, and let us say the values are 15, 98, and 74. Let us say these are the values in your linked list. This is the head pointer, which will point to your first node. Your first node will point to your second node. Second node will point to your third node, which is also the last node. And because this is a circular linked list, the last node will have a pointer back to the first node. This is how a circular linked list works. Let us say I want to delete one particular node from this list, and I am considering the first case. First case is deletion at the beginning of the list. So I want to delete the node 15, node having the value 15. How do you do this deletion? Because this is deletion of first node, generally, that is in singly linked list or in doubly linked list, it would be very easy. You simply have to make the head point to the next node. It is done. But because this is a circular linked list, there is a link existing from the last node of the list to the first node. So if you want to delete this first node off, you will have to remove the link from the last node to the first node. So because of this reason, even though it is in deletion from the beginning, the first step is to traverse till the end of the list so that you can change the pointer in the last node. Okay. So the first thing is to traverse till the last node of the list, starting from the head, go till the last node. So now you are standing at the node having value 74. This is the last node, you're standing there. The next step is to update the next of the last node to point to the second node. So you no more need this first node in the list. So what should you do? The next of the last node, that is this, should be made to point to the second node. So you will make this point to second node. This is how you make the next of the last node point to the second node instead of the first node. Next step is to update the head pointer to the second node. So head is what marks the starting of the list. What will I do? I'll make this head point to the second node. So my head is also pointing to second node, which means at this point there is no way of reaching this node at all. You can't reach this node at all, but it is still there in memory, which means you have to free this off using free operation. This is in case of a language which is not having garbage collector, automatic garbage collector. Otherwise, it will automatically do this. Either way, just keep in mind that memory should be freed by some means. So what happened now? This is out of picture, which means you have successfully deleted the first node. So your head is pointing to the new first node, which is 98. 74 is your last node. From there, you have a pointer back to the first node, which is 98. So this is how deletion at the beginning works. What is the time complexity? Time complexity should be, because you had to traverse from first node to the last node, already you had to go through all the n nodes, which means time complexity is order of n. What about space complexity? You didn't consume any extra space for this operation, so space complexity is order of 1. This is about deletion of the first node, that is deletion at the beginning. Let us reverse everything back. My node is here with value 15. Head is pointing to this. This is pointing to 98. 74 is pointing back to 15. The second case is deletion at the end of the list. That is, I want to delete the last node, which is 74. What should I do in this case? Similar to, keep in mind the checks of empty and whether there is only one node. Those checks goes without saying in any case of deletion in a linked list, be it circular linked list, singly linked list or doubly linked list. Always keep in mind, you have to check whether list is empty. You have to check with whether the list is having only one element, then get into these cases. So second case is deletion at the end. I want to delete this node 74. So starting from the beginning, from the head node, I have to traverse till the last node. Do I have to traverse till the last node? No, I have to traverse till second last node. This is the catch. So if I want to delete a node in a linked list, I should always go, I should always stop one node before the node I have to delete. So here I have to delete 74, which means I have to stop at 98. Then only I can delete 74. So in order to delete last node, go till the second last node in the list. From this position, update the next pointer of the second last node to point to the head node. So presently, my next pointer is pointing to 74. Remove this and make it point to first node. Okay, this is what I have to do. The next thing is, now you can see 74 is not pointed by anyone, which means there is no way of reaching 74 at all. So 74 is out of equation. So I can free off this 74 and remove it from the memory. So now my last node is deleted. I have a head which is pointing to 15, which is my first node. It goes to 98, which is the last node. From there is a pointer back to the first node. So it is maintaining circular linked list structure and the last node is deleted. What is the time complexity? Because I had to traverse from first node till the second last node, order of n is the time complexity because I had to travel through n minus 1 nodes. So that is order of n. Space complexity, order of 1 because there is no extra space used. Let us see the third case, that is deletion at a specific position. So in order to see that, I'm reverting these changes back. 98, I had one more node. I don't remember the value, let it be 72. From 98, there is a link to 72. From 72, it is pointing back to 15. So this is my circular linked list. What is the next case? In this case, I want to remove a node at some specific position. So let us say I want to remove the node at position 2. So what is position 2? This is position 2. 98 is at position 2. Let us say I want to remove the node which is presently at position 2. What are the steps? First thing is to traverse to the node just before the desired position. My desired position is 2. So I have to go only till 1. That is, I should stay at 15. I should not go to 98. I should stay at 15 and do the operation because I want to remove the node at position number 2. What is the next step? Update the next pointer to skip the node that I have to delete. So I am presently standing at 15 because 15 is the node just before the node I want to delete. And the next step is to update the next pointer of this node, whichever I'm standing, 15, to the next of next. I should make this point to here. So what does this do? This skips the second node which is having value 19. So how did I do this? When I was standing at 15, I checked what is the next of 15. So next of 15 was 98. So while I was standing here, I checked what is the next. I understood that is what I have to delete. Then I checked what is next of next. From 15 I understood next of next is 72. So I kept a pointer to 72 and I removed 15's next pointer and made it point to 72. At this point 98 is not reachable. I can free this off, so this is gone. That's how I delete at a specific position in a circular linked list. So whenever you're dealing with circular linked list, always keep in mind that there is a crucial condition that the circular quality of this list, the circular shape of this list should always be maintained. So whatever pointers you're changing, always keep in mind that the list should always be circular in shape. What is the time and space complexity of deletion at specific position? Time complexity, depending on the position, I may have to traverse position minus one number of nodes. So it is possible that if I want to remove the last node, it would be n minus 1. So because I have to traverse through the list, time complexity is order of n because of the traversal step. And space complexity is order of 1 because there is no extra space used.